So yesterday, for the kids who were in here, we went to AP Classroom and I individually told them to change their status if they were undecided and were going to go no for testing in the spring, or undecided and were going to go yes. Hopefully you guys did the same thing, but if not, you should do that because the deadline's coming up for ordering the tests. Then we went in and we just did a couple AP practice questions on biparts and decomp. Then there were so many notes, and I apologize. That's the longest notes I've had this year in here. They weren't long and difficult. It was just all of AB's L'Hopital plus a couple new. Today it's going to be reversed. It's going to be just one new L'Hopital, and the notes won't be as long, but it's much more complicated. So, and then worksheet number 8 from yesterday isn't due until here, I'll go. By the way, this next slide, if you're interested in the proof of L'Hopitals, I think some of you could understand it, but I'm trying to save some time. You'll be turning in worksheet 8 and 9 together by tomorrow morning. All right? So if you didn't start 8, it doesn't take that long. Like, who started it? It's not super labor intensive, right? It looked like a lot, but it went fast. Today's reverse. It's not as many, but it goes slower. So, we are going, and I wrote fun stuff on there because this section actually's got a lot of good math in it. So we're going to go into your notes for day 2 of L'Hopitals. But before we do that, I'm going to back up a page here, a couple, where I listed the indeterminate forms. You don't really need to memorize them. But yesterday, we talked about the 8, whoops, let me full screener here, otherwise we can't see it very well. Yesterday we talked about, for quite a while, just do you remember your AB? And most of them remembered most of it, but there are a couple things that were good to revisit in there. So, but this is AB, when they just explicitly fell in your lap as 0 over 0. Then I talked about, well, what if this happens? What if you get infinity minus infinity? And that's one where we had to get a common denominator so that it could go and pass off to being a quotient. And we did those actually secondary to the 0 times the plus or minus infinity. And those were the ones where you had to try to rewrite it so that maybe if it was like x ln x, you rewrote it as ln x over 1 over x. But again, you were trying to generate those quotients, right? These last 3 with the powers right here are what the next one's about, but it's all the same process. So 0 to the 0 is an indeterminate form. What do you think most people would say that is? Some would say 0, because 0 to any power is 0. What would others say? 1, because anything to the, you see why it's called an indeterminate form. Infinity to the 0, most people would probably guess it's 1, right? But infinity is not a number, it's a destination, so that one makes sense. The one that really bugs people is the 1 to infinity, because doesn't your gut just say it's got to be 1? Right? There's a bunch of problems with saying it's 1. It causes problems with other things. And if I have time, I'll show you later. But we're going to work with those 3 situations. So on the top of our notes, let's go right, that was where we had to, that's yesterday's. Here we are. So we're going to be getting either 0 to the 0, 1 to the infinity, or infinity to the 0 with these. These are all indeterminate forms. Really, you don't need to memorize them. I'll probably write them across the top of your test so you know when you hit one. The 2 you need to memorize is 0 over 0, infinity over infinity. So when I go and approach, excuse me, infinity, remember I can't get there, it's a destination, but as I approach infinity, I'm really thinking that x is going to infinity. And then I have 1 over something going to infinity. I can't really talk about 1 over infinity, but I'm going to, okay? What will the exponent be going to as the denominator goes to infinity? 0. So this is the indeterminate form I'm originally presented with. When I give one of these on the test, I always give 1 point to the whole process for you telling me which indeterminate forms you're getting. And if you maybe do 2 of the 3 right, it's only worth 1 point of an 8-point process, but I do like you to know which ones you're getting. Now, back to last year, whenever we would get an x or a variable in an exponent, do you remember how we get it out of there? Because I certainly, if I'm trying to go to L'Hopital's rule, I certainly can't have an exponent. Give me some sort of math move that'll, what'd you say? Natural log. So I'm going to take the limit away for 1 second, and I'm just going to say let y equal x to the 1 over x. I'm really now going to be looking for the limit as x approaches infinity of y. Does that make sense? So the first is just to get the limit out of there for a second. Then natural log both sides like you said, Jordan. And again, why am I choosing to natural log both sides? So I can bring the power out front from pre-calculus. Okay, now that I've used natural log, keep in mind at some point I'll have to undo it. How do you undo natural log? Exponentiate. That's going to happen at the end. Okay, but I will have to undo that at some point. Now I'm going to put my limit back on. Notice I'm writing a lot slower. I'll do a lot fewer, but there's going to be a lot more work than yesterday. Some of them on that worksheet, couldn't you just do in your head yesterday? That's not happening today. All right, so the limit as x approaches infinity of the left-hand side is equal to the limit as x approaches infinity of this right-hand side. And I'm going to do this first one, not skipping a single step. I've now just passed off to another indeterminate form from yesterday. As x approaches infinity, what does, let me see if I have my, I thought I had my highlighter activated from last hour, but as x approaches infinity, what does that part approach? 0. So now I'm passing off to a different indeterminate form, 0 times. And as x approaches infinity, what does the natural log approach? Infinity. Yep. As x goes to infinity, it goes there slowly, but it's going there, right? So I've passed off to this one from yesterday. This is another indeterminate form. It's not L'Hopital worthy, but it's getting there. This one is super easy. Remember kind of your goal. I'm going to just write equals here, so I'm not rewriting that left side a zillion times. That's almost a fraction as it is. Right, Lucy? Remember for L'Hopital's rule, we need to eventually get one of these guys. So if all I did that was a really easy move. Right, Connor? I now have a fraction, right? Which one did I get? 0 over 0 or infinity over infinity? Infinity, yeah. So I'm going to go like this, just to let LaRue know off to the side that I kind of know what I'm getting when I get it, right, Luce? Then you're going to write equals, and you're going to tell me you're launching into L'Hopital's rule. Because that's kind of important that I know you know when to go there, all right? L'Hopital's rule says, still approach infinity, do the derivative of the top over the derivative of the bottom, which is just 1, right? And I arrive at, when I put infinity technically, or I approach it infinity, what does 1 over x approach again? 0. That's not your answer because you natural log. You're going to undo it right now. Okay? So your answer isn't 0. Guess what it is? E to the 0. Now I'm going to show you why. So don't write equals e to the 0 because that would be a linkage error. But I'm going to re-put down what we got. We had the limit as x approaches infinity. I'm not going to make you show this, but for some of you who understand it, I'll show it on this first one. That's really what I got. I don't want the limit of the natural log of y. I want the limit as x approaches infinity of y, right? Now, I'm going to go over here and show you something. Limits are the most forgiving calculus operation there are. The sum of a limit is the limit of the sums. The derivative of the quotient of limits is the limit of the quotients. There's no quotient rule for them, product rule for them, chain rule. They are just, they're super malleable. And one of the things that you can do with them, watch this. Limit as x approaches 1 of like a function inside a function. What's the answer to that? Go ahead. Square root of 2, right? You can reverse the order of the operations. You could say, no, I want to take the square root of the limit as x approaches 1 of x squared plus 1. Notice now I'm putting the square root outside the limit operator, but it doesn't matter because what do I still get? Root 2. They can go under roots into exponents inside of signs. So like if Gabe is someday doing a limit as x approaches 0 of the sign of something and he's like, I don't know. He can say it's the sign of the limit as you approach. Does that make sense? They're malleable. So what I'm going to tell you is this is the same as the natural log of the limit as x approaches. And I won't make you show this. That's really what I have. So now to get rid of the natural log, I exponentiate. And what's e to the natural log of anything? They undo each other. So do you see how I got e to the 0? Will you have to show this, Callie? No. But no, be careful that if you get an answer of 2, your answer is not 2. What's your answer? E squared. Okay, so just beware. That was really slow, but how did it go? All right, we're going to try another one here. This one's one of the most famous limits of all time. All right, here we go. First of all, I'm going to pretend I'm approaching infinity. I've had 1 plus 0 to the infinite power. This is the weird one, 1 to the infinity. That's the original indeterminate form. And Zach, anytime you see that variable in the exponent, you know you're going to pass to natural log and you're going to do it immediately. You're going to get rid of the limit for a second. There's other ways to show this that are a little shorter in process, but they don't make as much sense. So I think you should just, I did it 1 year a shorter way, and the test results weren't nearly as good. Oops. Thank you. All right. Now, let's see if you have the process down after only one of them. Because if we've got it down, I might not do as many. What's next? Natural log. Yep. You want to get that variable out front. Perfect. We've only done one, but you're listening. So what's next? Yeah, that now put the limit back. And you can actually do all of this in one step a different way, but like I said, we didn't have as much success. So shortcuts are only good when they're smart cuts, and it made them dumb. All right, so there we go. Like 3 years ago, I'm like, I'm going to try this a shorter way. It did not go well. All right, limit as x approaches infinity of the left is equal to the limit as x approaches infinity of the right. It's kind of funny that Kevin's up on that's Kevin and Jabbar up there on my calculator. He's probably too old for you guys to remember him, but he was gone when I taught this, and he taught himself off of YouTube. And it doesn't do it this way. And then I got to the test, and he's a straight A student. He was great. He was one of the smartest ones I've ever had. But guess what happened on this kind? Bombed it, right? Because the shorter way that you're going to find if you Google it, it's going to mess with your head a little bit. So we're just going to leave this like this. All right, let's see if you remember what we do next. Right now I have infinity, technically, times the natural log of just 1. That's infinity times 0. Another indeterminate form from yesterday, but it's another one. So what that means is I'll be taking the limit, but I want to get it to a quotient. And this is where you got to be careful. The question is always, well, which one do I decide to flip? And guess what my answer? Because you have to flip one of them and put it in the denominator. What do you think my answer would be to that? Like if Jordan were to say, well, how do I know whether to flip this guy or this guy in the denominator? What do you think I'll say? Choose the easier one. That's one rule of thumb to put. Whatever one seems like it would be an easier thing to take the derivative of, because you're going to pass to L'Hopital's rule, and I know I don't want to take the derivative of 1 over natural log of 1 plus 1 over x. I'd much rather take the derivative of just 1 over x. So that's one decision. Make your life easy. So we're going to take and reciprocate that on the bottom. Good so far? Now, what indeterminate form do I have right here? This is the L'Hopital launcher, but which one is it? 0 over 0. It's the natural log of 1, right? Which is 0 over 0, and you're going to write that. Don't write equals, because it doesn't equal 0 over 0. You'll see what it equals when we're done, all right? But that's the form we're getting. So now we'll launch it to L'Hopital's rule. Don't drop your limit. How are we doing, Tobes? Now we do the derivative of the top. How do you take the derivative of the natural log of u? U prime over u. Okay, so we have to do u prime over u, or 1 over u du dx, whichever one you like better. So I'm going to do 1 over u times its derivative. And its derivative is 0, right? And the derivative of 1 over x, we've done that so many times. Negative 1 over x squared, right? I'm just going to throw it right here. It's kind of messed getting into my other layer there, but are you guys okay with that? All right. The derivative of the denominator is also negative 1 over x squared. That makes me go, so sweet! We love when that happens, Tyler, right? So now look at what I have left. Sorry, I got a little messy there. I'm now approaching infinity of a nice, simple quotient, right? So when I take this limit, what's this going to go to? 0. And what's the limit as x approaches anything of any constant? Remember, this is a function y equals 1. It's the e's first limit you ever, it's this function, right? And I'm going to infinity. What's the limit? 1. This is 1. That's not your answer. Your answer is e. This is the definition of e. It's one of 3. I'll link all 3 maybe onto a slide. I'm linking things that I don't want to show you because we're a little more pressed for time than normal. But this is the definition of e. It actually is how it inserts itself into the formula you've used with e that deals with your money. Remember that guy from Algebra 2? Did you ever wonder how e landed himself into your money? Right? Well, it had something going to infinity. As your money grew, time was going to infinity, right? And I will show you the proof of that too. But that's going to be extra. I think I'll have like a little video of some cool extra stuff. How does that sound? One will be called, because some of you are interested. And some of you are you're like, I'm maxed out. All right, we're going to try this one and see how it goes. And then I feel like you're getting it. So let's cruise along. I'm going to go faster. You ready? Here we go. First thing I do is I say, well, this is 0 to the sine of 0. Uh-oh, indeterminate form. I see that variable in the exponent. You guys go ahead. Tell me what to do. I'll go as fast as you talk. Go ahead. Natural log. Bring the power out front. Next up. Yeah, let's see what indeterminate form we have though here. Oh, we don't. You're right. Limit next. X is approaching 0 from the right-hand side. Anyone want to guess why we're approaching from the right-hand side? I am going to stop right. Why, Lodi? Because natural log. Yeah, you can only approach 0 from the right-hand side, or you're outside the domain. That was impressive. All right, and I accidentally, in my speeding up, this will be the limit. X approaches 0 from the right of sine of x, natural log of x. Excellent. Now, what indeterminate form do I have? 0 times negative infinity. Excellent. 0 times negative infinity. If you leave all those off, you get like a 7 or 7.5 out of 8. It's not the most important thing to put on what those indeterminate forms are, but I think the people who do should get the solid A, right? So let's go over here and talk about what we deal with over here. Would you rather take, which one do you think I'm probably going to put in the denominator? I think I will. I like 1 over sine. I'm not really sure I'm a fan of taking the derivative of 1 over the natural log of x. But 1 over sine x, not so bad. But now again, what indeterminate form do I have? Negative infinity over, careful, not over 0. 1 over 0 is infinity. Yeah, this is one of the plus or minus infinities over plus or minus infinities. Totally legal though now to launch into L'Hopital's rule, but tell me when you're doing it. Kind of fun, right, Gabe? So I've got the limit as x approaches 0 from the right of the derivative of the top, no problem. The derivative of the bottom, I'm going to give you, now if you're listening, we're going to be doing the derivative of 1 over sine of x. Somebody tell me how you want to approach that. Somebody said cosecant. Did you hear it? Okay, which is fine. If you remember the derivative of cosecant. Do you? Okay, well, let's not go there then. Oh, you just said it. Okay, she said it. When you're working with trig, are your friends sine, cosine, and tangent? Or are your friends cosecant, secant, and cotangent? Who do you like better? The first one. And you're, especially when you're plugging crap in, right? So you're going to want to go to sines and cosines. Put that in your mind. I told you 2 things to kind of have in the back of your head. Put the nicer thing in the denominator flipped. If you're debating which one goes down there, choose the nicer one. The other thing is when it goes triggy, try to push it all to cosine, sines, and tangents. So even though Jordan knew this, right, she's going to have to, she doesn't have to, but it's much more user-friendly to pass back off to cosine and sine. Do you agree with me? So keep in mind all this scratch work is me trying to take the derivative of the denominator, which was 1 over sine, which somebody in the back blurted a cosecant. I'm like, yep, Jordan said she knew her derivative, so I'm just following your train of thought. And then I'm going to say, well, what if Lodemeyer, right, is just like, I'm just going to launch into the quotient rule. Is that legal right here? And he goes low d high, which is 0, minus high d low, draws a line and squares below. Can you see it's going to fall out? The squaring below is going to be the sine squared, the d low is the cosine. It'll fall out into its cosines and sines. So there's a lot of different room for going, you know, as long, if you take different tracks, as long as it leads you back to that, I'm okay with it. So now I'll multiply by a reciprocal, right? This one's a little messier, the trig ones are. And I'll get a sine squared x on the top. And am I getting a negative? Yeah, I've got a negative, and I multiply this, and it'd be over x cosine x, right? I'm so close to this. Did I flip it okay?
Yeah.
I did? All right, now what do I do? Dang! I plug it in, and what do I get? 0 over, oh, barnacles. Now what? I told you it's not. It's a process. Do not like this is math at its yowza, right? Calc 2 is known to be the hardest of the calcs. It just is. It's more abstract than the other ones. So we've got the limit as x approaches 0 from the right of, and we have the negative sine squared x on the top over x cosine x on the bottom. But we haven't made any mistakes. And I still feel really good about it. And it's got my best friends, sine and cosine, right? So what do you think I'm going to do next? Whoops, I didn't L'Hopital it yet. I am going to L'Hopital it. That was a misplacement of the, now I'll L'Hopital it again. Well, I would have negative 2 sine x times the derivative of the guts all over. This is exactly what we're in AB right now. Product, quotient, chain, and we just hit implicit today, the first day of implicit. What do we do on the bottom? Product, first d second plus second d first. Now what? The top is 0 because of this, right? The bottom is 0 because of that. Part of it, but it's also plus cosine 0. And what's cosine 0? 1. This is actually 0 over 1. and you're like, the answer is 0, you'll get a 7 out of 8. Because remember, in all that process, the answer is not 0. It's e to the 0. The answer to this is 1. How crazy is that? What that means is, and I was going to graph it for you, but I think I want to let you guys, do you guys feel like you're getting it? And they take some practice, and I can't have you practice a ton because they take so long. So I kind of want you practicing with me. But it means if I were to go graph this right now on Desmos, as I approach 0 from the right, the y values will be approaching 1. Right? Maybe I'll go graph it later. I want to see what I have up here next and see if I want to pass off to, I think I'll do this as a review leading into tomorrow, just to be like, oh, let's try another one. I think we're going to go to the worksheet, and those of you at home, it's worksheet number 9. I'm going to have you guys try number 1 on your own, and then when that one's done, we'll go do 4 together. Now, since we did a bunch of examples in your notes, we might as well fill some homework out, especially since I talked so dang long yesterday. So let's do tomorrow. 8 and 9. Those of you who haven't started 8, don't like be super stressed out because that one honestly doesn't take very long. You guys are going to go try number 1. And then we're going to go do number 4 together. And this is a process where every step you have the opportunity to earn points, so don't skip it. You should be, if you're doing these at home, you shouldn't be looking up at your computer screen right now. They're all heads down working on it on their own. That should actually say 0 from the right, shouldn't it? The typo on the worksheet. Oh, well, anyway. Let's go fix that. Most people wouldn't even notice that, but you should. There's its start. Most of the answers are 1, e squared, e. Not sure which one this ends up being. All right, are you ready? If you're not done, that's okay. But half hour. So the first step, I'll define my y equals, right? I take the natural log so I can bring the x squared out front. I now reintroduce the limit. I think that's the best way to do this, even though it takes a few steps. It makes sense, right? Then the next thing, I've identified my indeterminate form. If you forgot that, not a huge deal. Certainly not an A breaker, but you might get a 94 instead of a 96 or something. Next up, I'm going to rewrite this side because I'm trying to pass off to my good friend L'Hopital. I think I would rather put the 1 over x squared in the denominator. Where'd you guys decide?
Yes.
I think that's easier. 9 out of 10 times it's a gut reaction and it's correct. So go with your gut. So the next thing I'll do is notice that I now have negative infinity as we approach 0 from the right-hand side over what? Positive infinity. Think about it. 1 over 0.00001 squared is like 1 over a trillion squared, which is a trillion. I made it up. I'm probably off a couple of tens, but you get it, right? That's going to positive infinity. All right, now don't forget this. You forgot that. You will lose a point. So there's detail, detail, detail. Next up, what do? I take the derivative of the top, 1 over x, over the derivative of the bottom. What's the derivative of the bottom? Negative 2 over x cubed. Yep, be careful with that. So negative 2 over x cubed. And so what ends up happening when I multiply by the reciprocal? What do you get? I get an x squared over negative 2, right? Negative x squared over negative 2. Some of you just had the negative x squared. You'd like get a 7.5 out. I think I saw 2 of those walking around the room. You, for some reason, ditched your negative 2. Not a big I have a speech impediment. Procedural issue. All right, now I get 0. Don't leave that, though. What's your answer? 1. 1. What do you think? You good? Now we'll go do why don't you guys start number 4, and then I'll leave you alone. We'll just talk about the bath real quickly, and then you can just work for 20, 25 minutes. Maybe finish this number 9. I don't know. You might say, they're so long. The backside's a mix. Okay, so we're going to go start number 4. What? Did you think these were all that?
No, I just think accidentally did something stupid.
Don't do that.
I won't next time.
It's a mixed bag of tricks on the back. It's either L'Hopital in your face, or you have to play with it like yesterday's, or you have to play. Actually, stop for 1 second. While I'm talking, then I don't have to repeat myself. Flip it over. See if you can decide, just based on appearance, which one is today's process. Find one. 15. Why does that stand out to you as today's? Variable in the exponent. Right? So when you're taking the test, whenever maybe late next week-ish, or early the week after that, there's still some stuff to do. When you see that variable in the exponent, that should trigger this, right? I bet the first 3 go right to L'Hopital because they're already fractions, right? That's my guess. So on a mixed bag, you just know how to do it. Let's go take a look, and you guys start number 4, and I'll start writing it up here. There's a lot of error that can happen when it's triggy to the triggy. It gets very triggy. So remember what I said about your good friends sine and cosine? You might want to be on it. I like to spread my wings on these, so I use a ton of paper. The key that I posted is like 6 pages long because I like to do one. I do a lot. to draw the graph. I think I'd rather do 1 over cosine, don't you? I wouldn't make it secant. You could. If you remember its derivative. Alright, how are we doing so far, guys? By the way, what indeterminate form do I have right now? It's a good question. That's actually a very tricky part of it. You have to watch up here, guys, because that's where I give the point for the indeterminate form is the pre-L'Hopital launch one. Does that make sense? As I approach pi over 2 from the right, the tangent function looks like, you should remember that from pre-calculus, that it's one of those periodic ones that goes like this. You remember that from pre-calc, right? And then it goes like that. But as you approach from the right, tangent goes to infinity, right? Natural log, as you approach infinity, goes to infinity, right? 1 over cosine pi over 2 is 1 over basically 0 that you're approaching, right? Which goes to infinity. Not a big deal breaker because it's not procedural, but that actually took a lot of thought, I thought. Yes? Oh, on the left. Yes, sorry. Did I write it wrong? Yeah. Oh, there it is. I was watching that when I drew my graph. You get it, right? No, because I'm approaching positive infinity. No, I'm correct on that. All right, so let's go take a look. Make sure that's over here. Do we get why I chose to do the 1 over cosine in the bottom? I'm glad we went to homework because these take a while. So this is my L'Hopital launcher. I have to say that. Okay, the derivative of the natural log of u is u prime. What's u prime? Secant squared. I'll be very careful. Over u, all over. You can either quotient rule, low d high minus high d low, draw a line and square below. Or if you want to think of this as secant down here, that's fine as well, but eventually I'd go back to cosine and sine. Does that make sense? So what is 1 over cosine? What do you want to do? Do you want to keep it in terms of cosine right now, or do you want to go secant tangent and then go back to, you're nodding at the second option? All right, so the derivative of secant down there is secant x tangent x. I don't like all this. I want to see, you don't have to see it in terms of sine and cosines, but I think it's a lot easier to see what cancels and what doesn't cancel and all that good kind of stuff. All right, so I think I'll pass off to it right now just because I'm not a fan of, I like sine and cosine. So on the top, I'll say 1 over cosine squared for this guy. Tangent is sine over cosine, but I have to be careful because it's over tangent. Do you see all the room for error here, right? So why did I say you have to be careful of that? When I divide by tangent, what am I really going to multiply by? Cosine over sine, yeah. And I could have cleaned up some of it too first, but I just, cosine over sine, I just really like sines and cosines. They make me feel a little bit more at ease than all that other garbage. All right, on the bottom, I have a 1 over cosine times a sine over cosine. So I'm just going to go sine over cosine squared. I haven't made any mistakes yet, have I, guys? Am I good? You can finish it off. Write this as a single fraction, cosine over cosine squared sine. And then I'd multiply by the reciprocal. Go from there. I think it's going to work out nice. Do you have to L'Hopital it again? No. What do you end up getting? 1. So e, right? They're saying they're getting a 1. You must end up getting cosine of, or sine of pi halves. Is that what you end up getting at the end?
I got a 0.
0 and then 1? I'm going to keep going just to make sure. This will have a cosine squared on the top and a sine on the bottom. Once I flip that over, I'm trying to be really careful, right? So let's go cancel. Gone. Gone. Did you guys get a cosine over sine squared? And cosine pi over 2 is 0. Sine pi over 2 is 1 squared. I get a 1. My answer's not 0. My answer's e to the 0. Crazy. All right, so you have 2 more like that, number 2 and 3. And then on the back side, it's a mixed bag. All right, so you go ahead and work the last 10 minutes.